Mass and weight. These are two terms we use interchangeably even though they're entirely different things. Because we've learned in high school that mass is the quantity of matter within something, while the weight is the force exerted on a mass due to gravity. So for example, here on our beautiful Earth, I weigh 75 kilos, but if I suddenly stood on Mars, I'd now weigh 28 kilos due to the weaker gravity. So if you ever felt you've gained weight, maybe you just happen to be on the wrong planet. But seriously, why does mass exist? Matter of fact, where does it even come from? Some people may point the finger at the Higgs field, but that's not the entire truth. We'll have to explore the world on the subatomic level, inside of the proton, where we'll find the standard model of fundamental particles. See, all fundamental particles here are just fluctuations of their respective field, kind of like bumps on the sand. But keep in mind, all these particles would actually be massless if not for the Higgs field, whose existence was confirmed by the discovery of the Higgs boson at CERN back in 2012. This is the so-called God particle that allows the existence of pretty much everything. It was first predicted by Peter Higgs and François Englert in order to explain how some particles acquired mass. But see, what's so fascinating about the Higgs field is that it exists literally everywhere in the universe, and the mass a particle gains only depends on how much it interacts with the Higgs field. However, it's important to note that some particles, such as photons, don't even interact with the Higgs field, and therefore have no mass. You can imagine the field as water in this cup, and the splash as the interaction. When I drop this penny, it causes little splash and therefore the mass is smaller. But when I drop this pebble, there's a larger splash and therefore the mass is bigger. So the Higgs field does indeed give mass. But like I said in the beginning, that's not the entire truth. If we look at the inside of a proton, the mass of the three quarks combined would only make up 2% of the proton's total mass. So where does the other 98% come from? Amazingly, it comes from energy. In fact, the three quarks whiz around each other at nearly the speed of light, generating a lot of kinetic energy and giving force that binds the nucleus through potential energy. And by rearranging Einstein's famous equation, find that mass mostly appears as potential and kinetic energy from whizzing quarks, in everything from your weight to stars and black holes. Maybe one day we'll find a gym routine that reduces that excess energy within us. But until then, we shall continue learning about this grand universe. Peace.